Now, as I was saying this, we have a collection of colors. I want to transform. I want the length of each string here. So green should give me, from this I should get 5, 6, 3, and 4. So if you remember, we had already done this. How do I transform each element of a collection to something else based on some logic? If you remember, we had used for some see colors, and we used the yield keyword, and in the logic, in the body of the for expression, we just return the size, c dot size. C is a string dot size or string dot length will give you the length of the string. So I said that whenever we use for yield, all these evaluation happens, the body gets evaluated, whatever value we get, that value will be stored in a collection, and finally that collection is returned. So I said that these things we have already seen. I will just try to write it once again here. I will just say val length is equal to, use the for expression, and I say colors. Here I say c dot length is also there, or size is also there. Both are same. My mistake. I did not use the yield keyword. So as you can see here, our input was this colors, and our output is this. Input was this. We transformed that colors into, each element was transformed. And I also said that instead of for yield, there is one more function that can be used. I said it's a map function. So here map is nothing but, map is a higher order function on collection. It is a higher order function. So let's understand that higher order function here. So we know that how a higher order function looks like. We will be using some of the other things also. I will not say list here, because list is one of the collection. You can also have vector, you can also have array, you can also have range, anything we can have. So in general, I'm saying it as a, in general, for all these things, I'm just saying a generic term as collection. Let's say we have a collection of type A. What I mean here is, you can have a collection of integer here, or we can also have a collection of string. So that's what I'm trying to say here. We have a collection of any type, and I said that on that I have a map higher order function. Map is a higher order function, means it has to take a function as a parameter. So the way it has defined its function is, it has already defined this function. The way it has defined is, what type of a function it will take. It will take a function that takes a parameter. It takes a single parameter, and that parameter data type is same as the collection type. I mean, if you have a collection, if you have a list of integer, that function will take an integer. If I have a list of string, that function will take a string. That's the reason both are A and A here. And it returns some other data type. I mean, what it is trying to say here is we can pass a function. That function takes the same data type as the collection data type, but it can return any other data type. It can return any other data type. And finally, the map function will return a collection of type B. So if you can map this, if we can relate this to our example, so it will be easy to understand. If you could relate this to an example. Map is a higher order function which takes a function. We have to pass a function here which will take the same type as the collection type, this one. If we are doing it on the colors collection, if you are doing it on colors collection, the function that we will be passing as a parameter should take string as an integer, string as an input parameter, and it can return anything else. Here we are returning a integer. If you see, it is taking a string. The function should take a string and it is returning integer. I mean, you can return anything based on your problem statement. My problem statement was to get the size here. Hence the B data type is being treated as integer. Finally it returns a collection which is nothing but this. So here, instead of the logic that we specify is specified in this function. The function is where you write your logic. So that logic will be applied on each element of the collection. To apply that logic on each element of the collection, this function is called for each element of the collection. I mean, it is called first for green, then this function is again called for yellow, then this function is again called for red, then this function is again called for blue. So that's how the map higher order function looks like. So we know how to call a higher order function. We have already seen the higher order function. We have to define some function, then we have to pass that function to map higher order function. Let's define a function. And what is our problem statement? Our problem statement is to get the size of each string. So I can define a function saying get size. I can define a function get size. It should take the same type as the collection type. My collection is a string. And I will just say s dot. So as you can see here, this function takes a string and it returns integer, which matches this data type. We should pass such a function which takes same type as the collection type, and it can return anything else. So here we are passing the same type as collection type, that is string, and it can return anything. Here we are returning integer. Obviously I can pass this function as a parameter to the map hierarchy. I can just say get size here. So this function is called, it returns the length, and I said that this function is called for every element of the collection, and it transforms each element to its length, just like we had seen the for and yield. For and yield also give us the same result. And I also said that we need not specify the we need not define the function. We can directly use the literal of the function. We know that this is the literal of the function. Parameter, parameter, and data type is also not required. Instead of equal to, we usually say arrow mark, then the logic. I mean to say length. When I say length, it's logic. We have already seen how to write a function literal. This is our function literal. In a similar fashion, we know that we need not specify the parameter name. We need not specify the parameter name. I could just say underscore dot net here. Now what you can, for easy understanding, we can always treat underscore as each element of the collection. That's the intuitive way of keeping the things in mind. Underscore is always each element of the collection. Now what is an element of the collection? It is a string. On that string we are calling the length. It returns the length of that string. Hence we get this result. So I hope the map higher order function was clear. Now there could be any other problem statement also. Let's say we had users will not be there. User 1 is this, user 2 is this, user 3 is this. We will also write user 4. Sorry, it should be user 4. I have 4 users. I can create a collection of those users. Now I have a collection of such users. So you can treat it as like a table, right? We can treat it just like a table. So we can say we have user ID Sam 22 something, 102, 103, 1004, John, Mike, Brad, 33, 44, I will just say 55, Chennai, I have Pune. So this is our collection. This is the first element. This is the first element of the collection. This is the second element of the collection. This is the third element of the collection. Just like we can treat it as a table. Now I only want name and city. From this I want to transform it to a collection which has only name and city, which should give Sam, John, Mike and Brad. City DLR, Chennai, Pune, and so I should get this result. So this is kind of a transformation. I want to transform my existing collection to something else. So how can I do this? So how can I achieve this? Any idea how we can achieve this? Now, whenever I say you need to have a function, I mean, we can use a map higher order function here, obviously. To that map higher order function, we need to pass a function. That function will take each element, it will take each element and transform into and only extract Sam and BLR. Now, what is each element? Each element is a tuple. It is a collection of tuple. Every single element is a tuple here. So we need to define a function that takes a tuple as the input parameter, because the function that we pass as a parameter, that function should take the same data type as the collection data type, because each element will be passed to that function. So we need to define a function. I will just, we will come to the shortcut later, even though shortcut will look much simpler. Even though shortcut looks much simpler, we'll come to that later, but we need to know how actually we arrive at the shortcut. So we need to, I will say, get name and city. I will just define a function called name and city. It should take a tuple, the tuple data type. This is how we specify. It should be, this is my tuple. It should take the same data type as the collection type. So, so what we want from this? We want name. How do I access name? I can just say name is equal to t dot underscore 2 will give you the name, because t is a tuple. Accessing the second element of the tuple is t dot. How do I get a city here? I will just say val city is equal to t dot underscore 4. Now, now I have to return name and the city, because if I just assign it, nothing will be returned from this. So I shall return a tuple with name and city. So as you can see here, this is a function. This function takes same data type as a collection data type, and it can return anything. But as per our logic, as per our problem statement, we want the name and city. This we can treat as A data type. This is our B data type. B could be anything. There is no restriction on the B. Only thing is the input parameter should be same as the type. Obviously, we can pass this function as a parameter. Here is a question. The question is, the first index, ETL index is 1. I did not get the question, Thiru. What's the question here?
How do you what is the index of that element? Like the first one will be a 0 or 1. So the t dot underscore 2, which you mentioned, right?
No,
So
T.
I thought it starts from 0.
No. T is a tuple. If you see, if I say var x,
Yeah, T is a tuple.
right?
The elements, the first element will be 0 or 1.
No, it's always 1.
The ordinal, always 1. Okay.
Right. It's not a collection, because if you remember, I said it is a class. It is a class, and underscore 1 is a member, underscore 2 is a member of a tuple.
Okay.
Right, Karnataka. Array index starts with 0, but the tuple will not start with the underscore one. I mean, underscore one is the member of the class tuple. Underscore two, underscore three, and underscore four are the member of the class tuple. Now I can pass this function as a parameter to the map higher order function. I have colors dot map, and I can say get name city. What is happening? Oh, why I'm using colors? So you can see that I cannot apply it on colors because colors data type is just a string. So I have to use it on users.map get name and city. As you can see here, it takes each string. First the get name and city we will be passing this as a parameter to the get name and city. It will return only name and city. Next, this element will be passed, it will return the only name and city. Next, the third element will be passed, we will get the name and city. So that's what we are trying to transform our data into. So that's the map higher order function for us. It takes any logic you can specify. You can specify anything here. And that logic will be applied. This logic will be applied on every element. As I said, it is a transformation. Here is a question. The question is, here users was a list, but get game and city was a tuple. No, it is like this, right? We had a users collection. On that collection, we are calling a map higher order function, and we need to pass a function. The function name is get name city. So this function takes users as an input. I mean each element of the users of the input, and it transforms to one more collection which is name and city. It returns a collection. So I did not save it. So you can see that here it is a collection. I can say val result equal to. I can just say val result equal to. We can see that result is a collection of tuple. The result is also a collection of tuple. Users is also a collection of tuple. But it has all the four elements in the tuple. Here we only have two elements in the tuple. I hope, Divya, that was your question, or was there any misunderstanding? So we just transform each element of the collection to something else. Suppose I want I think I did not show so we know that we need not define this function. We need not define this function. We can directly write the literal of the function. We take each element. You can have any identifier. I take each element. Only thing is, now each, what is x here? X is each element of the collection, and we know that each element of the collection is a tuple. Now how do I return only the second and fourth element of the tuple. I have to I need to return the logic I have to write here. I need to return a tuple x dot underscore 2 will give the name, x dot underscore 4 will give the city. So I can either do this, I mean, to be more readable, what I can do is I can write a body here. I can say val name is equal to x dot underscore 2, val city is equal to x dot underscore 3, sorry 4, and finally I can say the same logic I'm writing here. This whole function literal, I'm passing as a parameter. It should give the same result. But we can also we can compact our code by writing only this. So here is a question. No, the question here is whether x dot underscore 2 is same as x of 2. Whether x dot underscore 2 is same as x of 2. Now, when we say x dot underscore 2 here, x is a tuple. When I say x of 2 here, x is a collection. They are not same. You access the elements of the collection in this fashion. You access the elements of a tuple using this. I hope that was your question. So you can either achieve such function literals, or we can write the whole function literal itself. So this was our function literal, right? The whole function itself we wrote it. We took each element. This is our function literal. We took the same thing and we passed it as a parameter to our map hierarchy. We took the whole same thing, we passed it as a parameter to our map hierarchy. This is our function. We can also make it more compact, but we cannot use underscore here because x has been repeated 2 times in the body. X has been repeated 2 times. If we use the underscore, the compiler thinks that first underscore is the first parameter, second underscore is the second parameter. But map hierarchy function takes a function and that function takes only one parameter. It does not take 2 parameters. So I hope this logic was clear here. So you can try any other problem statement also. You can try any other problem statement. I want the last character of colors. How do I do that? Earlier what we did is we got the length of each string. Now what I want is I want the length last character of each string. I want N, I want W, I want E, and I want K. I want the last character of each string. So we can define a function which just returns the last character of a string. I can just say get char, get last char, which takes a string, and we know that we can just say string of 0 will give the first character of the string, but we don't want the first character. How do I get the last character? Take the size minus 1. Not found. What is not found? Oh, so we know that I can pass this to a colors higher order function. I mean map higher order function. I can just say last character. So it will only give me the last character of the string. Similarly, I need not define this function. I can take each string and I can just say is of the logic I can specify, the whole thing, the whole literal I can specify here. This is my literal s dot size. So that's our map higher order function. In a similar fashion, as you can see, here, the map higher order function, it takes a collection, it takes an input as a collection, and it returns a output also as a collection. It returns something. We usually call it as a immutability function, because the original collection remains as it is. The original collection is not modified. The map higher order function returns a new collection, and also since it returns, we can say it as a immutability function. Now suppose I want to do some mutability, like printing on the console. How can I do that? So if you see, so usually how we used to do here, we used to colors. So there we used to just say println C. So it prints something, and this expression does not return anything, because there is no yield here. The for expression does not return anything. It just prints on the console. Now how can I achieve the same thing in a functional form? To achieve the same thing in a functional form, we have a for each higher order function. Just like we have a map higher order function, we have a for each higher order function. Again, for each can be applied on any of the collection. You want to modify or update the collection, save the collection somewhere else. If you want to save the elements of the collection to a file, or you want to save the elements of the collection to a database, or you want to save the collection to some message queue or some global structure, so we can use the for each higher order. Just like map higher order function, for each higher order function takes a function, and that function takes a element. Data type is same as the collection data type, and it does not return anything. Since it doesn't return anything, for each also, the outer for each function itself also does not return anything. So we can say this as a mutability function. So what is the use case of this? You can pass any same as whatever function we pass to the map higher order function. Since it will be called for every element, this will also be called for every element. This function is also called for every element. But this function's responsibility is to do some mutability, save it to some database or save it to some file or write to a console. All those are the responsibilities of the for each hierarchy. So we can define a function called save to file. Each element. If it is a string, it will be a string. We just open file, write to file. Or we can define a function, define save to db. This takes the same data type as the collection type, establish connection, insert to db. Or we can say define a function, print to console. Same type as the collection type. Here we can say print ln that parameter. So whenever we want to do such a thing, we can write different type of mutability functions, and we can pass it to our for each. We can pass it here, save to file, or if you want to save it to a database, we can call save to db, or if you want to print it here, you can just say for each print to console. Now that's the use case of for each higher order function. It takes each element, it takes a function as a parameter, and that function takes each element of the collection and it returns unit. Its return type is unit, means it does not return anything. If it does not return anything, we know that it is a mutability function. We have to pass a function which does some mutability, so we can pass this. So suppose, so the same thing I can achieve, by writing colors dot for each, and we need to pass a function, and that function should take each element of the collection and its return type should be unit. We know that println return type is unit. We have already seen that. We can verify that whenever I say val x is equal to println, if I say, we can say that if you see here, it takes the same, this is a function, it takes the same type as the collection type is a string, and it returns unit. Obviously I can pass println function to our for each higher order function. Colors dot for each, pass the function, we get the same result. Suppose I can write any function. I can write any function which does some mutability. I want to print the characters of the collection. I want to print the first character, G, Y, W, and P. I want to print it. Printing is nothing but updating the console. So I can define a function, define print first character. So it takes a string, and I can just say println s of 0 will give the first character. I'm just defining my own function to print the first character. which takes the same type as the collection type, if you see this function, and it returns unit because our body contains the println. So obviously we can pass this function to the for each higher order function, and I can say print. As you can see here, this function is called for each element. This function is called for each element, and it takes each element and returns, I mean prints the first character. Does not return anything. It prints the first. We can directly use the function literal also. Take each element, and I will just say println s is a string, s of 0 will give you the. Okay. So that's the use of the for each higher order function. That's the use of for each higher order function. You want to modify something. I mean, whenever you want to modify the update or modify the, sorry, if you want to save the collection elements somewhere else, you use always for each higher order. You want to save the elements of the collection, you always use the for each higher order function. So I hope the for each higher order function was clear. And any questions still here? So if there are no questions, let's go ahead and see some more APIs. The next API that I'm trying to showcase is, let's say I have my colors collection. I want I want the strings whose length is greater than 4. I only want the elements whose length is greater than 4. If you remember, we had used for expression yield and iterator guard. If you remember, we had used the iterator guard. So I can say val result is equal to for take each from the colors, and I can say if c dot size is greater than 4. This I said as a iterator guard. If you remember, we are iterating for each element. C will contain first element, and it will check whether the size of that string is greater than 4. Size or length both will give the same. Whether size of green is 4. If it is, then I said yield. So we know that now we can see that we have used for with yield, for yield and iterator guard to filter some elements. We have used that 3 things to filter some elements. And whenever we filter certain elements, the data type doesn't change. We had a collection of string. If you remove certain elements, we still get collection of string. We don't change the data type. And I also said that the same thing can be achieved with a function called filter higher order function. So we have a collection of type A here. On that, I have a filter higher order function, It also takes the same function, it takes a function which will take the same type as the collection type, because all these functions will be called on each element of the collection. Obviously, they have to take the same type as the collection type. Now, now it returns a boolean. The function that we pass to the filter higher order function returns a boolean, and the filter higher order function itself returns a collection of the same type, because you don't change the collection here. Few of the elements may be filtered, but we get the same type as the collection. If it is a collection of string, we will have a collection of string itself, but few of the elements may be dropped. Now how it is dropped? It is dropped based on the logic written in this function. Whatever logic you write in this function, it will either return true or it will return false. So if the function returns true, then that element will be collected in the destination collection. If the function returns false for a particular element, that element will be discarded from the destination collection. So whatever function you write, I mean whatever function you want to pass as a parameter to the filter higher order function, that function should just return true or false. You write any logic. Just say you have some 100 records are there, or 100 elements are there. Some are error elements, some are good elements. So what we can use is, you check those records. If it is an error, just return false. If there is error, return false. If it is good, return true. So obviously in that case, you will be filtering all the error records. You will be filtering all the error records and you will be only getting a good record. You just write some function and you can write any logic. Finally, based on the logic, you return true or false. Just like you can say you may have some JSON record. Some of the JSON record may be corrupted JSON records, some of the JSON records may be good JSON records. So it could be a CSV record. Some of the records may be good CSV records, some may be corrupted CSV records. You parse that CSV record, and if it is a good CSV record, you return true. If it is a bad CSV record, you return false. So in that case, you will be filtering out all the bad CSV record and you will be getting only good CSV. Now the same thing, how can we apply? I want only the collections, only the elements whose length is greater than 4. So I can define a function. Some I will define ABC as a function which takes a string, and I can say s dot size should be greater than 4. Simple function. A function takes a string and it returns true or false. We can check this function by passing Scala as a string. As you can see, the length of Scala is, it has 5 characters. As a result, it has returned true. So it has to either return true or false. So it takes the string. If you can see here, this takes a string which is the same as the collection type. Collection is also a string, and it returns a boolean. Obviously, this matches our function data type. It takes a string and returns a boolean. Obviously, I can pass that function to the filter higher order function. On colors dot filter, pass this ABC function. And that's what we are getting. This function, as usual, will be called for every element of the collection. This function will be called for every element of the collection, and it will check whether that size is greater than 4. If it is 4 greater than 4, it will return true, otherwise it will return false. So whenever the true is there, the filter function will collect that element into the destination collection. Finally, we get one more collection, only certain elements will be filtered here. In a similar fashion, let's say we know that we also have users collection. Now I want all the users whose age is greater than 40. I want all the users whose age is greater than 40. How can I do that? So before going to that statement, we know that we need not define this function. We can directly use the literal of the function. Take each element, and check whether that size is greater than. We know that we can use the function literal. If you see in the body s is used only once, means we can make use of the. This is the input parameter. This is the body of the function, which together forms the function literal. We have seen this. Now in the body there is no repetition. Obviously we can use the underscore here. We know that intuitively you can think that underscore represents each element of the collection. Underscore dot size, each element is a string. That string size we got, then we check whether it is greater than. We can use the shortcut in this fashion. Most of the time you will see the code written in this fashion only. That's how we can apply the shortcuts on the filter higher order functions also. Now we have users here. When I have users, here the question is, how do I get the elements whose age is greater than 40? How can I do that? Right. We can directly use the shortcuts. I will not define the function. I will not define the function. I will not define the function here now. We shall directly use the shortcut itself. So while result is equal to on users, I have to call filter higher order function. What does underscore refer? Underscore, I said intuitively you can think about it is each element of the collection. And what is each element of the collection? It is a tuple. How do you access the tuple's age? Age is the third element in the tuple. Underscore 3 will give you the third element. So now we got the age. Now we have to just check whether it is greater than, I will say 40. So here this underscore represents a input parameter, a placeholder for the input parameter to the higher order function. I mean, to the higher order function, we are passing a function. This underscore represents the placeholder for that input parameter, which is nothing but a tuple. You can just think underscore as the input of element, collection element. Underscore is always a collection element. In this case, it is a tuple. In this case, it is a string because colors elements is a string. Users element is a tuple. Underscore is this tuple. To access the elements of the underscore, to access the underscore of the tuple, we just say dot underscore one will give the first element, dot underscore two will give the second element, dot underscore three will give the third element, which is nothing but our age. The third element is always the age. So we only got two records whose age were greater than 40, whose age was greater than 40.
So the first underscore represents the tuple and the second underscore represents the element.
Yes, yes. The represents uh, first underscore represents the element of the collection, which is a tuple here, and the second underscore is how you access the tuple.
So normally in normal way, how do you write this without any shortcut?
Without any shortcut, we have to define a function. I will just say val xyz. It has to take a tuple. It has to take a tuple because it has to take the same type as the collection type. Our collection type is what? Our collection type is a tuple with int string int string. And here I will return, I will just say val, to be more in detail, I will say val age is equal to a dot underscore 3. So we get the age. I will just check, I will just check age greater than 47. I mean, I can write in a simple, I have written it in a detailed fashion. I need not write in a detailed fashion. I can directly write a dot underscore 3 greater than. Both are fine. I mean, and just for readability purpose, I have written in a detailed fashion, but we can also write a function in this fashion. This function takes a tuple, and you can see it returns a boolean, which matches the filter higher order function data type. It should take the same type as the collection type. Obviously, this function is doing that. So on that, then on users dot filter, I can pass the function xy. Only thing is, we are directly writing this logic. If you see here, we are directly writing this logic here. Instead of a, we know that the shortcut is the input parameter can be replaced by an underscore. Our underscore is a placeholder for the input parameter. We are writing the same logic here. So the whole function is being passed here. So I hope it was clear. So that's how we write a filter higher order function. I mean, you write any logic. Probably initially you can try with defining a function. Gradually you can start writing shortcuts. But shortcuts, once you get used to shortcuts, it will be much readable and much intuitive, much compact. It will be more compact, and it will be useful. It will be more readable. But you can also pass a function also. I hope the filter higher order function was clear. In that case, we have to just return true or false. So you can write, to be more elaborate, I can define something like this. I can define val age is equal to a dot underscore 3, and I can say if age greater than 40, I can say return true, else. This is more elaborate way of writing your function. So if it is, sometimes we may have to write this because we may write a complex logic. After writing the complex logic, we have to just return true or false. Here it is only simple where age is greater than 40. If it is, return true, else return false. And the same thing we can apply here. It should give the same result. Here is a question. Yeah, here is a question. The question is what data type we use if there is alphanumeric data. Usually it will be string. So I can say val x is equal to 1. Sorry, it should start from a numerical value will not be started. Uh, Not found value. Oh, my mistake. Why I'm writing in this fashion? Everything it should be treated as a string. My mistake. Usually we treat everything as a string. That's the best way to treat a alphanumeric. Right. Thanks. Karnakar. Yeah, I did forget. Now we have one more higher order function which is again used mostly in the Spark also. So I am discussing only those APIs which are much more used during the Spark programming. Whenever you write a, most of the time you end up writing map transformation or filter transformation, for each transformation. Similarly, there is a reduce function as well. As you can see here, the map, the name itself says you map each element to something else. There is a one-to-one mapping from the source collection to a destination collection. So we can see that how many elements are there? 1, 2, 3, 4. In the destination collection, how many elements are there? 1, 2, 3, 4. So there is always a one-to-one mapping. If the source collection there are n elements, in after doing a map transformation we get n elements. There will be not a single more or a single less. There will always be the same number of elements as the collection. When we use filter, filter again, the name itself says that we shall be filtering some elements. If the source has n elements, the destination may have less than or equal to n elements. It may be because some records may get filtered, or none of the records may get filtered at all. Hence you will always have these many elements in the destination collection. As the name itself specifies, here also the name itself specifies. The name itself says that reduce. It reduces the collection. It takes the whole collection and it reduces it to a single element. That's the functionality of the reduce. It takes a function. This reduce is a higher order function again. It takes a function and it takes two parameters, and both the parameter type is same as the collection type, and it returns the same type as the collection type. And finally it will return a single element. It will not return a collection. As I said, reduce, the name itself says that it reduces the collection. It takes the whole collection as an input, and I mean it will operate. Better way to say is it will operate on all the elements of the collection and reduce return single element. Because collection may be 10, 20 elements, we are reducing into a single element, so I will just say return single. That's the main idea of the reduce. Now what all use cases can be solved with this concept? What all use cases can be achieved? I mean, what all problems can be solved with this functionality here? Operate on all the elements of the collection and return a single element. I mean, what all things can be solved with such functionality? Any guess on what functionality can be achieved? Or
Aggregation.
right, usually we can do the aggregations here. So reduce is usually used for aggregation purpose. So like we can do a count, we can do a sum, because we go through each element of the collection. If it is a numerical collection, we can achieve the total sum of those collections, because sum returns a single element. We can achieve min, we can achieve max, something, because min also will give the single element, max will also give a single element. So reduce could be used for such purpose. Now what does it take? It takes a function, and that function should take the same data type as the collection data type, that is integer, and it has to return the same data type as the collection data type, as well as the reduce itself should return finally a element which should be same as the collection data type. It cannot return something else. That's the limitation of the reduce higher order function. You cannot do all kind of aggregation, because the restriction here is it has to return the same data type as the collection data type. Yeah, here is a question. The question is why two parameters? Why two parameters? We will discuss that. We will see how the internals of reduce looks like, and I will explain that. So let's go with the syntax first. Later I will explain the internals. Now what does the syntax say? The syntax says that you can pass a function which takes the same data type as the collection data type, and it should return the same data type as the collection data type. Let's go with that. We have nums collection here, 4, 5, 6, 7. Let me define a function sum, and let's say I take two integers, and I will just say x plus y. Yeah, I will come to that question. I will come to that question. So we will just look into the syntax as of now. Now, what does this sum total function takes? It takes two integer, which is same as the collection type. Collection is also integer, and this function also takes two integer, and it does addition of those two integers. Obviously, it is returning that integer. It takes the same data type as the collection data type, and it also returns the same type as the collection type, which which matches our syntax. We can pass a function which takes the same type as the collection type, and it should return the same type as the collection. Only such function we can pass. Obviously, sum total function matches that data type. So we can pass this function to our reduce higher order function. I have nums, in that I have reduce higher order function, and I can pass some. So this is how we can use the sum total. But how the internal things work here? Before going to the internals, we can also say that we can directly use the literal of the function. We can directly use the literal of the function. Take x comma y, take x comma y, and just say x plus y. We can directly write we need not define the function. We have already seen such thing. And if you see the logic here, it's a simple x plus y. There is no repetition and there is no multiple expression. Each input parameter can be represented as an underscore. So I can use the shortcut as well, and I can say underscore plus underscore. So we achieve the same thing. Now it may be a bit confusing how the things are working here. What actually reduce does here. So to understand that, let's see what are those input parameters. That will explain everything. So I have val nums is equal to a list of 4, 5, 6, 7. This is our list. And I will try to use the function literal here because it makes easy to explain. And what we did is we said val result equal to on nums, we call the reduce higher order function, and this is our function literal. It takes two input, the function takes two inputs, and the logic is x plus y. Now what is x and what is y? How the reduce actually internally works, how the reduce function is internally defined to make use of this function literal. Whatever function literal we pass, it will be called inside the reduce higher order function, we know that. Now here the first parameter x is called accumulator. X is nothing but our called as accumulator, and it is always initialized to the first element of the collection. The accumulator, which is in case here is x, the first parameter, shall always be initialized to the first element. Now what is y here? Y is nothing but it's a iterator which will be iterating from second element to the last element. Y is a iterator which iterates. Iterate means it will loop. It will loop from second element to the last element. And why do we call this as accumulator? Because it accumulates the data. Initially it is initialized to 4, which means it is accumulating 4. Later what happens? We have this logic. After evaluating this logic, whatever value we get is again stored back in the accumulator. Hence we call it as an accumulator. It keeps on accumulating the data. That's how the reduce works. That's how the reduce works. The result is, or I will say, a return value is stored back in the accumulator. So the way the operation works here is initially x is equal to 4, because always the accumulator is initialized to the first element of the collection. Y will iterate from the second element to the last element. So y will be 5. Now what is the logic? The logic is x plus y. Logic is x plus y. X plus y is nothing but 9. 9 will be again stored back in the accumulator. Now y will be iterating to, again the logic will be applied. 9 plus 6, 15. It will be again stored back in the accumulator. And this time y will be iterating to the next element, that is 7. Now again these two will be added because that's our logic. Finally we'll get x is equal to 20. And finally accumulator is returned from reduce. Finally the accumulator will be returned from the collection. We know that the accumulator is also integer, so that does not violate the data type here. So that's how the reduce higher order function works. Mohan, I didn't get the question here. What was the question, Mohan? We are achieving the sum here. With the help of the reduce, we are achieving sum. That's true. Was that the question or something else? Right, final result is the total sum, running sum. And that's how the reduce works. The parameters are nothing but called as accumulator and iterator. So I have nums. So I have some other nums here, 5, 2, 4, 1, 8, 0. Now I want to compute min and max. I want to compute min using the reduce. How can I do that? Because reduce min of this is again an integer. If you want to compute max of that final result will also be an integer. We can always compute the min and max using the reduce higher order function. Now how can I achieve that? So we have to just define a function. We have to define a function something like this. Define, I'll say get min, which takes two integers. One is we can treat it as the accumulator, and one more we can treat it as the iterator. And I can say if x greater than x less than y, I can just say x, return x, else return y. So as you can see here, this function takes two integer and it returns an integer, which is same data type as the collection data type. So obviously this function can be passed to the reduce higher order function. I can say, so we know that 0 is the minimum element. 0 is the minimum element. No, we cannot directly use underscore greater than underscore or underscore less than. We cannot directly use underscore less than underscore because that returns a boolean. It returns a boolean, but we should not return a boolean. It should return the same data type as the collection data type. The accumulator should be the same type as the collection type. It should not change. So when we use a shortcut, also, we just use the function literal. We can just use the function literal. We take x comma y as the input parameter, and the logic we can write it here. If x greater than y, return x, else return y. I mean less than. So it should give the result. We cannot say underscore because underscore cannot be used here. Why underscore cannot be used? Because there is a repetition. There is a repetition. Underscore will not work. So if I want a max element, I have to just say okay. We can see that the way it works is same. The logic is same. The way it works here. We have a list val nums. What we have is equal to list of we have 524180. We have 524180. So whenever I say reduce and say x comma y, and I say if x greater than less than y, return x, because we have to return something else y. So now we know that x is initialized to, x is initialized to always first element of the collection. X is equal to 5. Y will be iterating from the second element to the last element. Initially y will be 2. So it will compare whether x is less than y. Obviously s is not less than y. This condition will be false. It will return y. Now x will be equal to 2. Because that return value is again stored back in the accumulator I said. Accumulator is nothing but x. Y will be iterating to 4. Again these two will be compared. Whichever is the small, again it will be stored in the accumulator. Y will be iterating to 4. Y will be iterating to 1. Whichever is smaller, it will be again stored back in the accumulator. Y will be iterating to next element, that is nothing but 8. Again, whichever is the less, it will be stored there, and y will be iterating to 0. Whichever is the less element, it will be compared and again stored back in the accumulator. Finally, this accumulator will be returned. This accumulator value will be returned. Hence, we achieve the max min. So I hope the use of reduce higher order function was clear. How the reduce higher order function works. But as I said, since it has to return the same data type as the collection type, you cannot use it in more generic fashion. It has a lot of limitation. The reduce has a lot of limitation. So instead of that, there is something called as fold. Fold left are there. Those APIs can be used. Those functions can be used. So we talked about different higher order functions. Hmm. And mouse is not working. And something happened to my system.